Hello friends. The examination of IIT JAM 2021 is on the way and you are able to keep the exam after 3 days. So it is an inspiring moment. It is an exciting moment also. So give your best in the examination and do your full best, I just say. I think you should give proper time to your study. You have taken so much proper time in the last days and you have managed with full dedication throughout the preparation. So I think that you must achieve your goal. After giving the exam you will feel very confident. Obviously before giving the examination please be confident, right? Because at some times when you feel confident then everything will be just cool and cool, nothing to tear up. So just give your best in the exam. And my wishes are always with you. So I want to see my juniors next year, okay, in my IIT, right? So be happy and don't take too much stress nowadays, and be cool and prepare some last minute trips like formula revising or revising some notes, but don't be hesitated. This is the main thing, right? So give your best and don't hesitate during exam too. Okay, so today we discuss some important questions, right? And regarding analysis or algebra, let's see them. Okay, so yeah, we have some question charts. So let's discuss. So first question is, just see carefully what is the first question. Let M is equal to the matrix. I will write the matrix 1, 2. Just minus 2, minus 1, 1, 1, 1, 4 and minus 4. So it is given, one is eigenvalue of M. So which are correct? Which are correct? That you need to tell. Which are correct, right? So the options are find minimal polynomial is you just say minimal polynomial is x minus 1, x plus 4, right? Second option is minimal polynomial is x minus 1 square, x plus 4. Third option is M is not diagonalizable. And fourth option is, D option is M inverse is 1 by 4 of M plus 3M. So you have 2 minutes to answer this question. You can check, you can stop the video at that moment and wait for 2 minutes or setting timer on your phone, and then start doing this and discuss this. And what it is, multiple select question, so there can be more than one answer, right? So write your answers, right? After seeing this question you have to solve it in 2 minutes. Just do it, right? So that's the idea here, right? Okay, well and good. So I think it's clear. Now I just solve it for you. You have noted this question. Yeah. The solution. Yeah. So we have this, I just say again, we have this matrix which is 1, 2, minus 2, minus 1, 1, 1, 1, 4, minus 4. So the trick in this question is using the given condition and try to find the minimal polynomial of this matrix. You know what is minimal polynomial? If you have a characteristic polynomial, I mean that polynomial which satisfies by this M, right? Where at M it becomes 0. right? That is characteristic polynomial, and we are able to discuss with minimal polynomials, right? So today we discuss it. So what is minimal polynomial of it, and given condition is 1 is eigenvalue of m. Okay, that is this. So use this fact. So try to find, trace of m is sum of eigenvalues. So what is trace? It is -4 plus 1 plus 1, which is -2, right? And sum of eigenvalues is lambda 1 plus lambda 2 plus 1, because one eigenvalue is 1. So lambda 1 plus lambda 2 is -3, right? Clear? And again, determinant of A m is product of eigenvalues. So what is the product of the eigenvalues? Lambda 1, lambda 2. So calculate the determinant of m. So determinant of m is, try calculating, -2 and -2 के बाद this one, -4 -1 -1 4 -2 -4 1 plus 2. Try calculating it and you will get what is the determinant. I just tried determinant m. 5 to the 10, and this is -2 -12. The determinant is what? It is coming -4, right? Is it clear? The determinant is -4, right? So the idea is that determinant is there, this thing is there, this thing is there. So lambda 1, lambda 2 is -4. So which lambda 1 and lambda 2 are satisfied by these two equations? Can you guess it? Yes, you can guess. So the answer is lambda 1 is equal to, you can take -4, and lambda 2 to be again 1, you can take, and that you see that it satisfies this. So you see this beautifully, right? So that's the idea. Now we discuss again. So can I drop it? You note these values of lambda 1 and lambda 2, -4 and 1. So yeah, I'll just drop it. Yes. So the minimal characteristic polynomial is, what is the characteristic polynomial? The eigenvalues you have taken. What eigenvalues you have taken? That are like x minus 1, x minus 1. These are eigenvalues, and then another one is x plus 4. Right? Is it clear? Then you have the idea is x minus 1 squared and x plus 4. Okay? So that's the characteristic polynomial of m. Right? So after it, we are able to find the minimal polynomial. We know what is minimal polynomial. It divides, I just say pm. So what are the possibilities for minimal polynomial? Right? We just discussed it. So it can be x minus 1, x plus 4, because the 1 and -4 are the roots of minimal polynomial also, because my 1 and -4 are the roots. So characteristic minimal polynomial की क्या possibilities हुई? mm can be x minus 1, x plus 4, or it can be, what is another possibility? mm can be x minus 1 squared, x plus 4. And you know what you know? That if minimal polynomial satisfies this equation or this equation, what is the difference? If minimal polynomial is this, then it is the product of two linear factors, right? And they are distinct. So, and there is no repetition. So you say that the m is diagonalizable. Otherwise you say that m is not diagonalizable, right? So you see that after doing these things, you will find that mm is this. This mm is this. Just is exercise. It's exercise for you all, right? You can check whether minimal polynomial is this or not. Is this? then it is not diagonalizable. Right? It is not diagonalizable. M is not diagonalizable. That's the idea. Whole idea behind, lying behind this. Right? You just have to see this carefully. Okay. So we now go through the options. What the options are that we see. So tell me what were the options. Right. So yeah. So first option was minimal polynomial of m is x minus 1 x plus 4. So A option is that m is this x minus 1 x plus 4, which is wrong. B option was the minimal polynomial is x minus 1 square x plus 4. So this is right. Right. C option was m is not diagonalizable. M is not diagonalizable. M is not diagonalizable. Is it? It is right. D option was m inverse is equal to 1 upon 4 m plus 3i. Right? You have to check this. Right? So we just check it. Right? So we have to verify is this right, true or false. So let's discuss this. Because m is invertible, if m is invertible, right, it is invertible. So you can replace right like this 1 by 4 m square plus 3m. Right, you can multiply both sides this of this equality by r. Then you will see that beautifully that what happens is m square plus 3m minus 4i is equal to 0. That's nice equation, and you see by solving it that you will get this. The idea is that m square minus 4m plus 4m minus m minus 4i. Then you will get this. What is the idea is that you get m plus 4, I just write it, m minus 1, I just say it, 0. Okay. So idea is that it satisfies this equation. But the minimal polynomial is this. This is the minimal degree polynomial, minimal degree monic polynomial. So how it satisfies this polynomial equation? So that's false. So this equation is false. This equality is false, right? So it is false. So again, our correct options are B and C. So if you have any query regarding this question, then you can post it in the comment, and I will definitely help you regarding this, right? So I think that's wonderful, and you have enjoyed it too much. So yeah, I think it's fine now, right? So yeah, we will go to next question. So for that we should have some break. Maybe I just pour some ink in my marker, right? So try thinking about it and understand it, right? This is very main thing, and yeah, okay. Okay, so I just go rub it. Yeah, just rub this question. Just rub it. Okay. So now we have another question, which is very good question. Let's discuss. So if you so again you have 2 minutes time. So be ready for it. Like P and B, nth prime number. When we enumerate the prime numbers, you know enumeration. Enumeration is just the prime numbers that is countable. So you can list them one by one, like x1, x2, x3, whatever the ordering you take. Okay, the prime numbers in increasing order say for example P1 is equal to 2, P2 is equal to 3. Like this I am just enumerating, right? P3 is equal to 5 and so on. Let S is equal to Sn. Pn plus 1 minus Pn, n belongs to n, and n is greater than or equal to 1, which is correct. Which is correct. I just solve it here, right? Which is correct. Which are correct, because there are many options that you can choose, right? So again it is multiple select one. So if you have this thing, another thing is limit supremum tends to infinity. Sn is infinity. Third one is infimum of S is less than infinity, and infimum of S is 1. And fourth one, limit n tends to infinity, Sn is greater than or equal to 2. Infimum Sn. Yeah, the idea is that in this question, because the idea is just very simple, because in this question you have to deal with supremum and infimum, and you know how to deal with them. Limit supremum, limit infimum, these are basic definitions in real analysis, right? So although you know them, but I will still recall it. Supremum is the least upper bound of the set. Infimum of the all the upper bounds, you say the least of all the upper bounds of the set, that you know. And upper bound is this the element which so all the elements are smaller than that, right? Limit supremum is that, I just recall this definition. Okay. Limit supremum is that if you have a set, like if you have a Sn is like this, and I just recall limit supremum. Limit supremum is that if you see this term, supremum of Sk, k greater than or equal to n, and this is basically infimum of n times to infinity of this, which is yn, you see, right? So try to understand it, right? So basically in this, if you see the set, y1 is what? Wait, first of all we write yn is equal to this. Y1 is that S1, S2, Sn, and so on. Let's write, yeah, it's going like Y1 is this set, S1, S2, S3, and so on. Y2 is this set, S2, S3, and so on. Y3 is this set, S3, S4, and so on. That's why it is. And you see, this set is subset of this set is subset of this. So y1 is supremum of this set, supremum is this set, supremum of this set. You see other way, that y1 is greater than or equal to y2, y3, and so on, right? So and if you take this sequence yn, if you take the limit as n tends to infinity, right, then you see that because it is a decreasing sequence and it will converge to infimum, right? So let's see that. Firstly we form this y1, y2, y3, and so on. Then you see this thing, Pn plus 1 minus Pn. I just don't recall. You just see 3 minus 2, it is 1. So S1 is 1. Like this, S2 is 2, S3 is 7, 2, because P4 is 7, and so on. So you see that the difference between the consecutive prime numbers is increasing. It is increasing. It may be 2, it may be 4, right? It is increasing thereafter. And similarly, you can see on the y2 space that it is also increasing, right? So you see on y1 you see that supremum is coming out to be infinity. It is not an R, right? And in y2 it is again going to be infinity. In y3 it is again going to be infinity. So basically you have to take care of the limit of this yn, and limit of this yn is going towards infinity, because every limit, you see y1, y2, y3, they are all going towards infinity. So the limit is going to infinity, right? Because infinity is a symbol, right? It's not a number. You just see it is a very big number, and y2, y3, y1, y2, y3, they are all proceeding towards the larger numbers, and as they are increasing enough, as this is a decreasing sequence, okay, what is the idea is that it is going towards infinity. Okay, nothing else stuff. So yeah, I just say to see this limit n times to infinity by n is again infinity. Yeah, that's it. So limit of supremum Sn is infinity. That's it. And again, because basically in limit supremum we take the infimum of supremum, but here y is decreasing and all terms are infinity, so you don't care about it. You can write limit n tends to infinity, yn is infinity. That's it. Similarly, you can check this thing. It is greater than or equal to 2, and supremum of S. What is supremum of this set? You see, it is going increasing and increasing and increasing. Then it is proceeding towards infinity. So it is again right. Infimum of S, and infimum of S is what? You see this set basically. I don't write it. You see, 3 minus 2 is 1. So first term is 1, right? So infimum of S is 1. This is right. And infimum of S is less than infinity. It is again right. Right? Basically, this thing you have to check. Limit infimum Sn is greater than or equal to 2. That is one thing that you need to check. Okay, we just try it. Oh. So, just see that. Limit infimum is opposite of limit supremum. What you see here, you consider the sequence Zn is equal to infimum of k greater than or equal to n Sn, Sk. Right? Then infimum is basically the limit of Zn, and you have to consider infimum of all these sets that I have written earlier. Okay, so what is the infimum of S1, S2, Sn? Z1 is what? Tell me. S1, S2, S3, S4, what is the infimum? It is 1. Right? What is the infimum? It is coming out to be 1. Right? Okay. Okay. And another is Z2. What you see? Z2. What is the infimum? Infimum of the set. It is coming out to be again 1. Yeah, it is again 2, right? And again you see Z3, it is again coming out to be 2. Yeah. So basically you see Z1, Z2, Z3. As you increase forward, you see that Z1, Z2, Z3 are increasing, increasing and increasing. So again, because at some time you have to go at 4, because that terms will be cut out, you can see geometrically or anyway. So it is increasing and it goes to infinity. So infimum Sn is greater than or equal to 2, right? Obviously, right? That is fine. So you have to find the limit of this set for the D part. For D part. That's tough. That's important and that's easy. Okay. So that was second question. So one more question I want to do is linear operator, right? So let's discuss that also. After that we stop. So yeah. Let's discuss.